So the next thing we're going to take a look at are derivatives of trig functions. We already know how to do the derivative of the sine of x and the cosine of x, but I didn't tell you the derivative of tangent, cotangent, secant, and cosecant. And you're going to see why in just a moment. I had to sort of hold off until we got to this section. But the first thing I want to do, just to make our list complete, is I want to write down that the derivative of the sine of x is, oh, you know that. What's the derivative of the sine of x? I hope you said cosine x. And the derivative of the cosine of x is negative sine x. Our first two trig derivatives, we already dealt with those. We kind of saw where the formula comes from by looking at a graph and trying to figure out some slope things there. The derivative of the tangent of x. Any clue how we could start to approach this? I'm not a big fan of tangents. Any clue how we could start to deal with this problem? Well, how about we rewrite the tangent in terms of the sine and the cosine? This is like asking us to find the derivative of the sine of x over the cosine of x. Maybe now you see why I had to wait till this section to show you this rule. What am I going to have to use to find the derivative of that thing? We need the quotient rule. So here we go. Actually, I think I can continue over here. Low cosine x. D high, derivative of sine x, is cosine x. Minus high minus sine x. D low is another negative sine x. Draw the line and square below over cosine x in parentheses squared. Well, cosine x times cosine x is cosine x in parentheses squared. Hopefully you remember from last year that the shortcut way you can write that is cosine squared x. That means cosine x times cosine x. Plus sine squared x over cosine squared x. I really hope that the top of that fraction kind of jumps out to you, because that was probably one of the most important trig identities that you learned last year. What's that numerator going to become? Hopefully you remember that first Pythagorean trig identity that says sine squared theta plus cosine squared theta equals 1. So we're going to get 1 over cosine squared x. And actually there's another way I can write this. 1 over cosine is the same as secant. I'm going to say this is the secant squared of x, so then I don't have to deal with fractions. The derivative of the tangent of x is the secant squared of x. The derivative of the tangent of x is the secant squared of x. I am not going to go through the proof of the derivative of the cotangent of x. However, it works in a similar way. You say it's the derivative of the cosine of x over the sine of x. If you feel like trying it, go write that out. I'm just going to give this to you. One thing I really like about the trig derivatives is they come in pairs. If you kind of know how sine works, you kind of know how cosine works. Same with tangent and cotangent. If you know how tangent works, you know how cotangent works. When sine and cosine came in pairs, one was positive, one was negative. Same's going to happen over here. Derivative of the tangent of x was a positive thing. The derivative of cotangent is a negative thing. My equivalent function of like secant x is going to be cosecant x. I'm going to say this is the negative cosecant squared of x. The derivative of the tangent of x is the secant squared of x, and the derivative of the cotangent of x is the negative cosecant squared of x. Next, the derivative of the secant of x is going to equal the derivative of, okay, your turn. How do you think I could rewrite the secant of x? Well, secant of x is just 1 over the cosine of x. So how about I write it like that? And then I can go use my quotient rule. Low, d high. Low is cosine x. What's d high? Derivative of 1, derivative of a constant, is just 0. Minus high, minus 1. D low, derivative of cosine x, is negative sine x. Draw the line, and square below, square the cosine of x, you get cosine squared x. So I need to clean this up a little bit. This part's just 0, and this part becomes a positive sine x. Sine x over cosine squared x. It's not the best form to write it in, so here's what I can do. I can say that this is 1 over the cosine of x times sine x over the cosine of x. Take a moment to sort of convince yourself that this thing is the same as this thing. If you were to multiply this times this, yeah, you'd get sine x over cosine squared x. What's 1 over cosine x? Secant x. What's sine x over cosine x? Tangent x. The derivative of the secant of x is the secant of x times the tangent of x. And that's our 5th trig derivative. I'm again not going to go through the derivation of the derivative of the cosecant of x, but I'm going to use the fact that these things all come in pairs and have parallel structures. First of all, you want to guess, is this derivative going to be positive or negative? I hope you said negative. I'm not going to use secant x. Instead, I'm going to use cosecant x. I'm not going to use tangent x. Instead, I'm going to use cotangent x. The derivative of the cosecant of x is the negative cosecant of x, cotangent of x. You are going to need to memorize these 6 trig derivatives. Let me rewrite them one more time, just so they're all in one place and condensed without the work in the middle. Oops, looks like this pen. Yep, that pen's about done. Okay. The derivative of the sine of x is the cosine of x. The derivative of the cosine of x is the negative sine of x. I'm just going to write them all down, then I'll have Edpuzzle pause, and you can copy them all down in one place. The derivative of the tangent of x is the secant squared of x. The derivative of the cotangent of x is the negative cosecant squared of x. Derivative of the secant of x is the secant of x tangent of x. By the way, make sure you don't say secant tangent x. That means nothing. Secant of x, tangent of x. And the derivative of the cosecant of x is the negative cosecant of x, cotangent of x. Edpuzzle's going to pause. Get those all copied down in one place. Let me show you 2 examples now of using these trig derivatives. Y equals x cosecant x minus the cotangent of x. Y equals x times cosecant x minus cotangent of x. I think over here, you need product rule. I think here is just one of those new rules that we learned. Edpuzzle's going to pause. See what you can do to find the derivative of this. So y prime is going to equal, I need product rule on this thing. First, x times derivative of the second, negative cosecant x cotangent x, plus second cosecant x times 1. Okay, moving on. Minus derivative of cotangent x is negative cosecant squared x. Do need to clean this up a little bit. Y prime equals negative x cosecant x cotangent x plus cosecant x plus cosecant squared x. Guess I could do some factoring. Whatever. I think that's good enough. One more that I want you to try. I'd like you to find the derivative of f of x equals the tangent of x over 1 plus the tangent of x. Again, Edpuzzle's going to pause. See what you can do. Low, d high, secant squared x, minus high, tan x, times, okay, derivative of 1 is 0, derivative of tan x is secant squared x. Draw the line, square below. F prime of x equals, okay, this is secant squared x plus secant squared x tangent x minus tan x secant squared x. Oh, that's kind of nice. They're going to cancel. All over 1 plus tan x, that thing in parentheses squared. So f prime of x is going to equal secant squared x over 1 plus tan x, that thing in parentheses, squared. And there we go.